Hello everyone, I'm Bhumika Mohan. In this video, I'm going to talk about a topic related to data structures and applications, that is stack operations. Contents of this video are stack definition, then I'm going to talk about stack operations, program on stack operations, and lastly, applications of stacks. Now let's talk about stack definition. A stack is a linear data structure in which the insertion of a new element and removal of an existing element takes place at the same end represented as the top of the stack. LIFO, that is last in first out. This strategy states that the element that is inserted last will come out first. To implement the stack, it is required to maintain the pointer to the top of the stack, which is the last element to be inserted because we can access the elements only on the top of the stack. Basic operations on stack. In order to make manipulations in a stack, there are certain operations provided to us. First, it is push to insert an element into the stack. Next, pop, it removes an element from the stack. Top, it returns the top element of the stack. Next is empty. This returns true if stack is empty, else false. Size, this returns the size of the stack. First, let's talk about push. Adds an item to the stack. If the stack is full, then it is said to be an overflow condition. Algorithm for push, it says begin if stack is full, return, end if, else increment top, stack of top, assign value, and else end procedure. Now let's talk about pop. Removes an item from the stack. The items are popped in the reversed order in which they are pushed. If the stack is empty, then it is said to be an underflow condition. Algorithm for pop is begin. If stack is empty, return. End if, else store value of stack of top, decrement top, return value, and else end procedure. Here is a diagram for the pop function. Now, let's talk about top function. This returns the top element of the stack, and algorithm for top is begin, return stack of top, and procedure. Now comes isEmpty function. Returns true if the stack is empty, else false. Algorithm for isEmpty is begin, if top is less than 1, return true, else return false, and procedure. Program and stack operations, here is an example for it. Here it says include stdio.h, include stdlib.h, and we are defining max as 3. That is hashtag define max 3. You can change the size according to your requirement. Int s of max, int top equals -1, void push int item, int pop, void display, void main. Here inside the void main we are declaring int choice and item. Next, we are taking a while loop, and then we are taking printf statement, and we are displaying the menu. Then here we are taking printf and a new line, and one is push an element to stack and overflow demo. Second is pop an element from stack and underflow demo. Next is display, and last one, fourth, that is exit. Next, we are printing enter your choice and scanning the choice. Next, we are taking switch case and entering choice. And here we are taking case 1 as enter an element to be pushed, and we are scanning the item. Next, we are taking push item and we are taking break. Case 2 item equals pop. If item not equal to -1, printf element popped is %d item. Break, and here a break is there. Case 3 display, break. Case 4 exit, 1 default. Here the default condition statement is we are printing please enter valid choice, and it is break. Next, we are taking void push int item. If top equal to max -1, we are printing stack of overflow and return. Top equals top plus 1, s of top equal to item, and then int pop int item. If top equal to -1, we are printing stack underflow, return -1, close braces. Item equals s top equal to top -1, return item, void display, int I. If top equal to -1, we are printing stack is empty, return, Printf, here we are printing stack elements are for I equal to top, I greater than equal to 0, I minus minus, we are printing the elements of the stack and closing the braces. Applications of the stack are infix to postfix or prefix conversion, redo undo features at many places like editors, Photoshop, etc. Forward and backward features in web browsers. Then stacks is used in many algorithms like Tower of Hanoi, tree traversals, stock span problems, and histogram problems. Next, we use stack in backtracking, which is one of the algorithm designing techniques. Some examples of backtracking are denied to problem, n queen problem, find your way through a maze, and game like chess or checkers. In all these problems, we dive into some way. If that way is not efficient, we come back to the previous state and go into some another path. To get back from our current state, we need to store the previous state. For that purpose, we need a stack. In graph algorithms like topological sorting and strongly connected components, then it is used in memory management. Any modern computer uses a stack as a primary management for a running purpose. Each program that is running in a computer system has its own memory allocations. String reversal is also another application of stack. Here, one by one, each character gets inserted into the stack. So the first character of the string is on the bottom of the stack and the last element of string is on the top of the stack. After performing the pop operations on the stack, we get a string in reverse order. Stack also helps in implementing function call in computers. The last call function is always completed first. Stacks are also used to implement the undo or redo operation in text editor. Thank you.